Hello class, welcome to our second video about special triangles. This time we're going to talk about 30, 60, 90 triangles. Now, similar to a 45, 45, 90 triangle, a 30, 60, 90 triangle has special proportions involved with it. First, remember that a 30, 60, 90 triangle is going to have angles that measure 30, 60, and 90. It is important to be aware of some vocabulary. First, this is the hypotenuse. And then, to reference the other legs of the triangles, we call the shorter one the short leg, and the longer one the long leg. Being aware that the short leg is always opposite the 30 and the long leg is always opposite the 60. So, with the 45, 45, 90 and the 30, 60, 90, there are proportions involved. And the proportions are the same no matter what triangle you're dealing with. So let's kind of keep things simple for ourselves. The side opposite the 30 is going to be 1. And the hypotenuse, we're going to say is going to be 2. So let's do Pythagorean theorem to figure out what would be the long leg. So it would be 1 squared plus x squared equals 2 squared. And you would move the 1 over to the other side, so x squared equals 3. So x, your missing side, in this case your long side, is going to be the square root of 3. And every single 30, 60, 90 triangle is going to be a scaled version of this. So make sure that this triangle ends up in your notes. This is kind of, I guess you could say, like the easy version of the triangle. Now, if I knew that the short leg of my triangle was, we'll say 5, okay? Keeping in mind how we did things with the 45, 45, 90, this would be 5 root 3, and this would be 2 times 5, which is 10. The hypotenuse is always double the short leg. That's kind of how that always works out. So if you knew the short leg was 100, then the long leg would be 100 root 3, if that's the 30. And then the hypotenuse would be 2 times 100, which is 200. Now, again, if this is not in your notes yet, write it down because it is very, very, very infinitely important. Because not everything is going to be simple like these two problems that I just made up. Okay? So we'll keep drawing our triangle the same direction for now. So let's say that here's our 30, and we're going to say that this side is 10. And we will say this side is x and this side is y. So we want to find x and y. We want to find the missing sides. Now, every single 30, 60, 90 triangle is just a larger or smaller version of the one we just talked about, 1, root 3, and 2. So it doesn't really matter which one you find first if you're setting up a proportion. And almost always for these, you're going to end up setting up a proportion for something. The measurements aren't always going to work out nicely. With the 45, 45s, a lot of times you can figure them out in your head. But with these, it's not always that simple. So I almost always set a proportion for 30, 60, 90 triangles. So again, first find the pair that match up. This time we have the long side. Remember, the long side is always opposite your 60. So 10 and root 3 match up. So 10 over root 3 equals x over 1. Those would be the long sides. So this is going to be one proportion that you solve. The other proportion that you solve will also be 10 over root 3. And that will coincide with the hypotenuses, which is y over 2. And then you can cross multiply or do some mental math, depending on how things work out for you. Like this one is x over 1. So it's just x equals 10 over root 3. Oops. Got ahead of myself there. Again, you are good math students, and you are always going to rationalize your denominator. So this is 10 root 3 over root 9, which is 10 root 3 over 3. That would be your x. The second proportion, you could solve by cross multiplying, or since it's just a y by itself on the top, if you just multiply both sides of the equation by 2, you will make the fractions cancel. So this is 20 over root 3, because remember it's 2 over 1. Again, you're a good math student, and you will always rationalize your denominators. So you have 20 root 3 over 9, root 9, which is 20 root 3 over 3. And it might not seem very obvious, but I did just say that the hypotenuse and the short side are always double. Well, this is 10 root 3 over 3, and that's 20 root 3 over 3. So it actually is double, which is convenient. Let's try another one. I'll try to trick you by drawing the triangle in a different way. So 30 and this side, that's 30 degrees. And we'll say this side measures, we'll do a root. How about root 10? So again, and we'll call this x and we'll call this y. Again, every single 30, 60, 90 triangle is a scaled version of the basic 30, 60, 90 triangle, which has the long side of 1, the short side of 1, the long side is root 3, and the hypotenuse is 2. Now, notice that I drew this in the same direction that my original purple triangle was drawn. This is on purpose, so it helps me see what matches up a little bit better. So my 2 is going to match up with my root 10. My 1 matches up with my y, and my root 3 matches up with my x. It is very, very important that you remember your 1 is always opposite your 30, your root 3 is always opposite your 60, and your 2 is always your hypotenuse. Otherwise, you will not end up with correct answers. So each proportion that you set up is going to be root 10 over 2, because those are the two that match up. And it equals y over 1. And then root 10 over 2 equals x over root 3 this time. Now you have lots of different options to do from here. Here, this is y over 1, so it's just y. So this one actually wasn't too bad. This is just 10 over 2, root 10 over 2. Now remember, the root 10 and the 2 don't cancel each other. This next one, you can cross multiply if you want, or you can multiply to get rid of the fraction. I personally like multiplying to get rid of the fraction. It's going to take less steps. So here the root 3 and the root 3 cancel, and you are left with x. And now we have root 30, because when you multiply two roots, you just multiply the numbers on the inside, over 2. And root 30 does not have a perfect square. So that's just your plain old simple boring answer. And even though these answers are both fractions, it's okay don't worry about it. Let's do one more together, and then we'll call it quits. As long as you know your 30, 60, 90 triangle, and you set up the proper proportion, these are going to go very simply for you. Let's say that this side is 9, and this is x, and this is y. So I have the proportion, and again, take the time to draw your 30, 60, 90 in the same direction that your current triangle is. And again, I'm going to set up a proportion. So find what matches up first. So I have 9 and root 3. So 9 over root 3 has to equal, let's see, x over 1. And then 9 over root 3 has to equal y over 2. This one, since it's x over 1, it's just x, equals 9 over root 3. And again, rationalize your denominators. So I have 9 root 3 over 3 equals x, because again, root 3 times root 3 is 9, and the square root of 9 is 3. This time, you have 9 over 3, which will reduce, because 9 divided by 3 is 3. So you have 3 root 3, which equals x. This next one, I would multiply both sides by 2 to get rid of the fraction. And so we have 18 over root 3 equals y. Then rationalize your denominator because you are a good math student. You have 8 root 3 over root 9. Sorry, 18 root 3 over root 9, which is 18 over 3. And you can simplify 18 over 3 to give you 6 root 3, which is y. Again, sometimes you can simplify those problems and the fractions go away. Other times, like this one up here with the 10 root 3 over 3 and the 20 root 3 over 3, they did not reduce. You will come across several very strange answers from time to time with very strange radicals in them. Don't feel like you are incorrect. Make sure you do some practice problems before you start your quiz.